This conference will now be recorded.
Right. So we're going to discuss in this session overall why we need to learn MongoDB and why NoSQL is gaining the market. And when we have sophisticated RDBMS systems in the market since very long, still these products are gaining the market. What are the use cases these are actually fulfilling over compared to RDBMS? And what are the benefits we do have in terms of availability of the data and computing power and there are many different benefits we do have compared to RDBMS with the NoSQL products, and they fulfill a lot of use cases which are not fulfilled by the RDBMS systems at the moment. So the overall objective of this discussion all about what is NoSQL, why NoSQL is actually started using, this must be used nowadays, and why NoSQL must be used when RDBMS systems are there. Benefit over RDBMS. This is the main agenda of our discussion. We will spend a lot of time on benefits over RDBMS using the NoSQL products, basically. And we'll compare the terms. What do we use in NoSQL? What do we use in RDBMS? The terms are different, basically, and different types of NoSQL. Like RDBMS, we do have many products, right? Oracle, SQL, Postgres, Greenplum, there are MySQL. So there are a lot of products, right? The same way in NoSQL also, we do have different, products which are there in this family also. And RDBMS will follow the strict ACID property, and MongoDB follows the base property. What exactly the difference between these two, we'll discuss at the end of the session today. So let's get into the what is NoSQL basically. NoSQL generally not only SQL it stands for, but NoSQL says that RDBMS is SQL. It follows the strict structure when you have to load the data. NoSQL does not follow any structure at all. It is a schema-less product. It's a dynamic schema product basically. It does not follow any principle that RDBMS follows most of the cases. Not all the cases, but most of the cases, like it doesn't have any interrelationships or referential integrities, and it does not follow any schema. You don't need to define any schema. It'll build the schema on the fly automatically. There are many things, like differences we do have. So basically these products started very lately, in 2010 onwards. These products got good attention from the market. So but these are all started by one of the person. NoSQL was introduced by Carl Stroji in 1998 itself. So he used to call it a file-based database basically. But these products did not get good market during that time because there is no too much of data. We had all RDBMS system that used to suffice the requirement of the market. But now data is absolutely versatile. If you compare RDBMS systems, RDBMS system only serve the fixed structure. Okay, let me open and show a few things before I get into the next slide. Basic difference between the NoSQL and RDBMS. Very basic. Anyway, there are many differences and advantages we do have. We will just look at it quickly. Right. So if you look at any RDBMS system for that matter, if you have a table, you have a structure, you have to feed the data with a predefined structure. If you exceed the structure, you cannot insert the data. If I check here, I have some data in this format: t number, t name, and address. If I'm trying to insert the data into that table, insert into teacher table values, just for the sake, why I'm inserting, I'll tell you anyway. Example. Okay, and I'm just inserting one record. If I try to insert this record, it will take the record. The reason being is I'm following the structure what I defined in the table. If I'm giving extra email address, assume a case, I wanted to insert email address of the person. Suddenly, all of a sudden, this is a requirement came from the project. in the beginning days they did not think about email need to be added, but later on they wanted to. So whenever you wanted to add this extra column data, you must define that structure. If you don't define, it won't accept. All RDBMS will follow the fixed rigid schema model. First define the schema, define the structure, then load the data. If you don't define and you're trying to insert, it does not take the data. You must define, as simple as it is. When it comes to the MongoDB, MongoDB does not need any schema to be defined. So example, if I go to db.student, there is a collection. Uh, I'll talk about, no need to, just understand, try to follow this. Just so I wanted to give a little bit of difference. So you have a S number, S name, and address. I wanted to add email address also to this existing data. So I'm going to insert some data, db.student, insert. Why I'm showing this in the beginning itself, just to make you understand, basically. So S number 5, maybe S name, I'll give it as Gautam. Okay, and address is Hyderabad, just for the case. Right, now there is an email address I'm adding on the fly. Okay, so you no need to define this. It will take that column, that field extra automatically. It is inserted. If I go and read this particular document, we'll call it as document. It is a row actually. I did not define email as a field, as a row, as a column, but it picked up. If I wanted to insert some more data, like I'll insert some other data. 6. Maybe I'll go with the Rajesh, Bangalore, some just for the sake. And here I'm giving here rajesh.gmail.com and phone number. I'm adding extra field. So I did not define this. So I'm inserting this. It accepted it. So you no need to define anything. It just take the data on the fly in any format. There is no schema definition you have to do by default. You can enforce the schema by giving external conditions that we will talk as a schema design in the MongoDB separate module. One module itself we will dedicate it. By default, MongoDB does not follow any structure or design in the background. It accepts any kind of data. This is where this is products are getting popularized. Nowadays, things are agile. Data is structured, semi-structured, unstructured. So semi-structured, unstructured, not served by the RDBMS systems. When the things are agile, when you have a huge bulk volume of data, if you wanted to change the data type itself, it is a huge headache. It is a huge headache to change data type on the large volume of data set and the RDBMS. In the MongoDB, there is nothing you have to define as such as a data, like you don't need to define that, a varchar and varchar kind of. It will take the data as you insert the data as a data type automatically. I don't need to like give the numbers as integer, string as a string. It will pick up the data based on you mention. If you string, it has to go in the quotations. It is a number without the quotation. That's it. It will take the data and it will follow the boolean values. It will follow the different data types. So we'll see that. So why I am discussing this part especially right now, you need to understand that RDBMS does not support the unstructured data or semi-structured data, basically. Semi-structured data in the sense they don't follow some structure, basically. They can be in any format. Sometimes, you will get to some data, some other time you'll get some extra fields automatically added because of the business requirements. You don't need to define in the backend. So in the real world, the people no need to think about the backend development, backend schema development, I mean to say. In the front end, they can add the fields. It is dynamically build the fields in the background. So the focus more goes towards the deliverables of the front end, not towards the back end. So it is agile on the fly. So this is something which is attracting the market nowadays, because if you see the any logs, maybe logs are very very important about every application. If you go to the YouTube yourself, you browse some videos, it will automatically give you your based on your interest of videos how it is doing, because it's taking your every click in the background and giving you some related or similar videos, so that that will make you to click and watch, so that they'll get the money in the background. So how it is happening? It is happening through the backend, data collection. So this kind of data is going into the Mongodb or NoSQL families only, not the RDBMS. There are a lot of use cases where RDBMS does not do the job. That's where the NoSQLs are doing the job nowadays. So let's move on. I'm going to pick up point by point. I mentioned every point. We will discuss point by point anyway. NoSQL represents a group of products and various related data concepts for storage and management of large data sets. Generally, all NoSQL products are big data products. They deal with a large volume of data. RDBMS is also equally capable, but there are limitations with RDBMS. What are the limitations? Again, I'll just wanted to talk other in terms of data limitations. Let's talk about this. I'll explain everything that we have in this slide. First, let's get into the understanding of few things, then we'll enter into the slide side. If it is a RDBMS system, guys, what do? You'll have a data drive, you'll have the log drive, you will have the tempdb drive or system db's drive, all that. And as the data is growing, you will add more drives and you stripe the data to different drives. Okay, you added the drives, it is about to fill up, you expand the drive, you keep expanding the drive to accommodate the data. The more data is coming, the more drives you might get it and expand also as data is growing. When the data is growing, you have to give the more number of CPUs, more RAM on the same machine. So you are adding the CPUs, a lot of CPUs and large volume of memory to support the data retrieval. That is good enough. But when the data grows bigger, TBs of data, example, you have 10 TB of data in a single database, assume a case. So in RDBMS, if data becomes more big, doing the maintenance activity is a challenge. If you cannot do maintenance activities like rebuilding index, reorganizing index, update statistics time to time, your performance will degrade down the line because of data will fragment. But if you wanted to do the rebuilding of index on 10 TB, it might take days basically. Business cannot afford to give that downtime. So when the data becomes too big, though it processes the data, but if you cannot perform certain maintenance activities all the time, right? So that becomes a limitation of the product basically, because everything can be processed or written to one single server generally, right? You write into in all RDBMS systems. If you take SQL Server, if it is always on, you write into one server, other server will sync up, right? All the time write copy is only one. If you take about Oracle rack concept, multiple servers you write into, it is okay, but physically only one storage. You can write into multiple servers, but ultimately one storage you write it. So all our write operations are choked at one point, right? The limitation of this product is one machine or one target you write at any point of time. This is the RDBMS limitation. When the data grows beyond the control, you cannot do the maintenance activities. If you cannot do the maintenance activities, your data definitely will not, retrieval will not go well, because your data will fragment down the line. If it is fragmenting, you cannot serve the data as requested, because of unnecessary data will be loaded into buffer. So now, if you take about all NoSQL family, they follow the horizontal computing model. What exactly the horizontal computing model? Let me explain. So these are all called replica sets, which will be in the sharding. I'll explain this architecture. Just let me draw this, and then I'll give an idea how NoSQL families really work, basically. So these are all applications, application servers. So let me just give a brief introduction about almost all products will work this way only. So applications here, and this is something router or mongoose, basically, or mongoose server. And this is a config server where all the schema information will be there. And these are all replica set, which is equivalent to called as replica one, which is equivalent to shard one. Okay, shard one. Just a minute, I'll explain how these products are so efficient than RDBMS in terms of data processing. in terms of data availability also. There are a lot of limitations on the RDBMS compared to this. So now what happens here is this router server will contact the config server will distribute the data to all the servers equally. So if if I'm sending, assume a case that if I'm sending 90 GB data to the backend, what happens here in the backend? It will distribute the data 30 GB here, 30 GB here automatically. It does automatically. We're going to see this in practical in our classes anyway. So 30 GB here, 30 GB here. So whatever the data you're writing into the Mongo, in the Mongo cluster, which is called sharded cluster, data get distributed to different machines. Not here in RDBMS systems, your data is actually is a DR only. It's not a write redundancy. It is a only read redundancy. You might get it. You'll have a multiple servers. You can read from here, but write can only happen only on one server at any point of time. In RDBMS products, here you can write into multiple servers, read from multiple servers. So based on your data set, your data got distributed, each copy again 30 GB, 30 GB, 30 GB, again protected with the multiple sets here. Okay. If one server goes down, this will pick up the load automatically with all the data. So it is fully automated failovers. You don't need to do anything, any extra. One single command does entire configuration, and it is a self-healed technology. You don't find too many issues in the Mongo compared to RDBMS. This product is very small compared to RDBMS product anyway. So here, what I wanted to stress is, in all NoSQL family, all will follow the horizontal computing model. This word is very, very important. Horizontal computing model. So what exactly horizontal computing model is? One single request served by the hundreds of servers if you have hundreds of shards, if the data is more. So here the data is becoming more and more. You keep add the shards. When I add the shards, it automatically rebalances the data into all the shards. If example, I have on these three servers together, I have assume a case that 10 TB data, 10 TB data into these three shards. So data become too big, then I added one more shard. As soon as I add the shard, 10 TB data will automatically distribute. So here 3.3 TB before, 3.3 TB here, 3.3 TB here. As soon as I add the another shard, what happens? It does the distribution automatically in the background. Just add the node, it does the 2.5 TB here, 2.5 TB here, 2.5 TB, 2.5 TB here. On the new node, automatically it will distribute data equally. With one single command, you add the shard, it does the data distribution internally to load balance the data automatically. It does internally. You don't need to worry. We're going to see that how data is migrating also in the background. In visual, I will visualize you also how data is moving, how chunks are moving. Data will move in the form of chunks, basically 64 MB chunk, a 32 MB chunk. We will see that how it moves the data in practical. I load the data, chunks will be formed, chunks will be migrated. We will read the reports and everything basically. So as data is keep growing, you keep adding the machines, it will keep scaling it. There is no limitation on this. That's how these products are big data products. Any technology you take in the NoSQL family, all will follow this horizontal computing model. Horizontal computing model means for a single request, there are hundreds of servers can perform your operation, depends on the data set. If you have a small data set, maybe two shards, little more, three shards. More and more it is becoming bigger, you keep adding the more shards. So this way your data is still growing enormously. Still the servers will scale because of the multiple servers is responding for your request. This is one thing. Data scalability is more with the NoSQL family than RDBMS because it follows the horizontal computing model, whereas RDBMS will follow the vertical computing model. Anything you do in one machine, okay, anything you do in one machine basically. So one machine it will reach the limitation of that size. If it reaches too big, you cannot do the maintenance. If you cannot do the maintenance, you cannot do the maintenance, you cannot get the performance, expected performance levels, right? So that kind of limitations can happen in a single machine. So this is something, it is not, like serving the use case that I wanted big data to be performed, it is not doing it. though it does for like it is doing, but it is at the cost of a lot of resources. Maybe you keep more RAM, all of data is getting cached, maybe it will speed up the processing, but you need to deploy more and more resources as data is growing. At one point you don't do the any maintenance, all of your data trying to come into buffer. So how much you RAM you are giving it, it does not suffice the requirement. So it will create a lot of issues basically. Okay, so that use case actually fulfilled by the NoSQL family. Any data, petabytes of data you can operate on single cluster, petabytes, 1000 TBs basically, more than that, in fact, because by default this product again compress the data by default. If I load one TB data, it will become even 100 GB also by default. The default encryption by default it will follow. You don't need to do the data compression at all. It does inbuilt. Whatever data you see inside is actually it is a compressed data. 1 TB data can become 100 GB, even less than that. 90% to 85 to 90% it will compress the data if it is text data. If it is videos, PDFs, scan docs, photos, this kind of data it won't compress much. But if it text data, it does compress by default. You don't need to apply that. That is not there in the RDBMS. You have to compress based on your requirement. Here it is not like it compress by default. And also this hardware what we are using for this product is no need to be so sophisticated. Why? Because you are not actually loading one server, you are dividing the load. When you are dividing the load, even the lower class, I mean to say, it's not so sophisticated, normal commodity hardware, normal hardware also can scale, because you are not flooding one system, you are distributing the load. That way MongoDB can run on the cheapest hardware. You don't need of server class hardware, because you are not hitting one machine. The availability, if you look at, guys, if it is RDBMS system, you have a data files mapped into respective drives. If one drive is down, what happens? Entire database will be down. One drive is down, one file is corrupted, entire database will be down. Single point of failure. So NoSQL families are not like that. One chunk is completely down for some reason, it will operate with the available data. It will operate with the whatever the data is available. It does not depend on the one chunk. One chunk means one shard. Other shards will operate though one shard is completely down. So you are operating with available data though one chunk of data is gone. In RDBMS,
Ravi,
it's not like, yeah, go ahead.
sorry, Ravi. Shard is, you can think it of as another server, right? Actually.
Yes, it is another server. There
Oh,
are three
okay. Okay.
servers. These are three servers, in fact. Whatever the data you have, one table, or just assume a case one table has 1 TB data. Assume a case one table has 1 TB data. So 1 TB data is went into here, 250 GB, 250 GB, 250 GB, 250 GB. So
Okay.
these 1 TB data I can get it from the router server. I'll read, if I read a condition, the condition query will be given to the config server. Config server read your condition, send your request to respective servers to get the data, because it knows where the data physically sitting, and
Okay.
it
Okay.
gets data from all the hardware servers, different hardware servers.
Got it.
Right. So this kind of thing is not available in RDBM systems basically. This is a drawback of the RDBM systems. You cannot do the striping of write operation, and reading also you cannot do striped read. So this will read from all the servers, one single read. It will write into all the servers at a time. If you, even if you go to any technology in RDBMS, you will read from only one copy, one of the copy, not from multiple at a time, because data always sit in one server. You dependent on one node when you are reading it. So there is no distribution of read, there is no distribution of write. So this is actually a huge drawback for the data that is coming into the market. See, nowadays everybody are generating the data, and data is coming in different formats. You are the, everybody are the data generators now. Everybody have the mobile, everybody have the different apps installed. Each app has every app people are gathering the data of the user, right? If you are using the WhatsApp, your data is backing up in the WhatsApp servers. They're backing up, they're using it. Every message, every video what you are sending it, that data is enormous. The people, these people cannot serve that kind of data where social media data is absolutely going to the NoSQL family only. You cannot serve that request to the with the RDBM systems. RDBMS never scale. If you go to the Facebook people do videos, upload the videos, upload the photos, scan docs, or any text, any they are loading it. No one see any downtime at all, because there are hundreds and lot of servers are serving each request. So no one see the downtime at all. Even one server is down, there is a replica of the servers in the background. One set has a two more copies in the background. More than that, you can go up to 50 copies if you really wanted for single copy to protect it. So the more servers, the more protection. The more protection, more availability. So availability wise, it is winning it. Storage wise, it is winning it. By default, it will compress the data. And the scalability wise, the right scalability wise, it is winning it. And it is a dynamic schema. It is not rigid schema. There also it is winning it, right? It can accept any format, any data. In fact, you send the data in any format. See, these were having 3 columns. This column is a 4 column. This has a 5 columns, right? So there is no definition for it. You load the data in any format, it will accept it. So there is no rejection of the data. That's what people need nowadays. So you use an app you will generate the data of different types of data. Every time you send a different type of data. So how that system need to accept that? Everything you are sending going through the server only, basically, right? That backend system need to accept the data. So to accept dynamically, you need a NoSQL family. SQL family does not allow by default, by design, anywhere. If you are exceeding 1 column data without a data definition, it does not accept the data to take into the backend system, right? You have to plan the schema, then load according to your schema. If you are exceeding or violating the schema rules, you're gone. You cannot insert the data. In the NoSQL side, it's not like that. All of the products are like that almost. They are schemaless and dynamic schema model. They do follow. That's these products are third generation, like latest generation products. We'll call it a third generation products. Okay, because of it is actually serving all use cases. You can go with the fixed data model, you can go with the unstructured data model, you can go for the semi-structured data model, any kind of data, in fact. And the processing also, the better than the RDBMS product. And all these are a lot of NoSQL family are open source. They encourage a lot of open source. MongoDB, you can process 50 TB data. We are using 50 TB data in the community edition without a single penny. 1 rupee also our company is not paying for 50 TB data processing on one of the cluster, because it's running on the community edition. Community edition as good as enterprise in terms of data processing, except automatic monitoring and automatic alerting and auto backups, data encryption, and there are the connection security, like encryption of connections when you're sending it. There are few features which are missing, but data processing wise they are as good as enterprise. If you take about RDBMS SQL Server, you have the free edition which is called Express edition. It can go up to 10 GB only. Latest it used to be only 2 GB, now it is 10 GB. If it goes beyond 10 GB, it won't operate. So there are absolute limitations, right? This product does not have any limitation. It has it You can run as much data as an enterprise, except some features are missing. So we are using 90% of our Mongo servers are community. 90%, in fact, only 10% are enterprise. So we are saving 90% of the infrastructure cost towards licensing. If you take about all RDBMS, your infrastructure cost is only 10%. 90% of the infrastructure cost is only licensing only. Licensing itself is 90% of your infrastructure cost towards RDBMS product. That's how it is basically. Too costly. So that's why you see nowadays everyone is trying to save the money, and non-critical products are where like some critical products are also running on the Mongo, because even it supports OLTP transactions. Basically, you can do the all sort of transactions what you do in the RDBMS, but there are recovery wise it is weak compared to RDBMS. How it is weak we're going to talk about. In terms of recovery, RDBMS is so powerful compared to RDBMS. RDBMS does not control it, but you can control it the replica set. Replica set will give you equal benefits like RDBMS, almost, not 100%, 95%. 5% still there is a gap. We will discuss about data recovery in the Mongo. There I'm going to compare it because I am also working on the SQL Server DBA, right? Different products I do work. So RDBMS products I know, NoSQL product also I know. So I'll compare it when we are going through the course anyway to get the more clarity. Now come back to the slides. You
Ravi, I
definitely
have a
follow.
question. Let's say here, right, in the yeah, in this diagram, let's say you're inserting the data which is not organized, right? And if you keep on inserting data, let's say if you have terabytes of data, when you're reading, right, data is mostly scattered here, right? Will it affect the reporting kind of activities?
No, see, when it is scattered, it has the information where each data, each range is sitting. Okay. If you are hitting only one machine, IO will go to saturation. When you are reading from a lot of servers are fetching the data for your request and giving you the data that will be more faster. If it is
Do
a
we
small,
have indexing concept here? Here also, here as
yeah,
well?
of
Okay.
course, indexing is a very big topic for us. We have to spend 3 classes on indexing itself, 2 classes in fact. Indexing plays very bigger role everywhere. Data will scatter here also. We scatter in the sense physical and hardware. How you modify the data based on that, the locations will keep changing it. To track it efficiently, you need a more index so that directly address will get. We will see the execution plan. There is a performance tuning I'm going to cover in depth in the Mongo.
Okay. And
In the
also,
course itself.
one more question followed by that. Let's say if you want to do a maintenance, we can do as thread wise. It's not like entire, right? Entire all
You can
threads, right? Let's say.
you can do entirely because all the servers are doing the maintenance at any like you're submitting the maintenance task from here. It will
Mhm.
go through here, it will submit the task from all the servers. Each chunk has a small range of data. It can do the maintenance task quickly, right? Because you distributed data already. One does not have all the data like
Right.
RDBMS.
Got it. Uh-huh. Got it.
That way you
Yeah.
can, even data is huge, still you can actually do your maintenance tasks in a limited window.
Okay.
Getting
Got
it
it.
right? Yeah.
Got it. Got it. Thanks.
Yeah, good question.
Uh, Ravi, you are talking about the community edition, right? So
Mhm.
so how you are handling in case of any issues, Ravi? So you'll be opening a ticket with the community forum,
Uh,
or how?
Good point. We have a support actually. We buy the support with some cost every year. Generally, initial days we used to go for support. Nowadays we are not going because we know a lot of things in the Mongo now. We almost like more than the Mongo guy we know now better because
Okay.
gone through a lot of use cases and hardly we'll go to them when we have a product bug generally.
Okay.
Support also with the enterprise 10% in enterprise we have, right? With this we get the support basically. But when we
Okay.
raise against the community edition, you need to go for the paid community model, support model. We are paying towards this roughly, they said like close to, I don't remember that amount, but they are paying fancy amount only, not in the sense like it is maybe nearly 60,000 K. I'm not sure. They are paying per year. Recently, the support got renewed actually recently, like 4 months ago itself. Every year they renew. It is yearly wise basically. But you look at the infrastructure cost. What you're saying, 90%. This
So who will
Mongo.
be actually supporting the issues, Ravi? So it's like open source community, something like that, a group of people, or how it is?
No, 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 no. There is nothing you need to go to. MongoDB has a full support model. No third party involved in this product. Not like
Oh,
Postgres, like you have
correct,
EDB, you have different. Here,
correct.
you don't have anyone here. Only MongoDB distribution. No one is involved in the support model in terms of distribution of the product as well. No one, absolutely entirely it is with the MongoDB support model. You get entirely right from the scratch to end. If something goes wrong, MongoDB or person will walk in and even help you also. If it is enterprise stand, it is a community edition, you have to pay for that, but there is a full support, end-to-end support, any kind of issue.
Okay.
That's a very good actually. They do release a lot of releases, very frequently with all the enhancements. They're trying to catch with the RDBMS almost with all the features what RDBMS is giving. So soon down the line, maybe over the NoSQL grow more than the RDBMS because of it is trying to catch base all the features that RDBMS is doing.
Got it. Okay.
Yeah. So let's come to the next slide, guys. This is something what we discussed, but I'll recap everything what I'm going to do, what we discussed. So not only SQL is a new set databases that is not based on relational database management principles. So whatever we discussed, like it is a dynamic schema model, it goes to horizontal computing, it has a inbuilt data compression and scalability, availability, all are better than the RDBMS, except the recovery. Recovery is weak, and security also little bit weak than the those other products. This product can install without security enabled. They should have enforced, but it will install. We're going to talk about what are the actual caveats we have with this product. We'll touch base when we start the topic by topic. For now, so it does not follow the RDBMS principle, and it is a big database. All NoSQL fall under big database only. These are made for the new generations. New generations means who are using all different types of data. No one is wanted to follow one fixed model. It is agile. People wanted everything on the fly. No one is waiting for something to happen. Basically, something they wanted on the fly. That's where people are moving towards. So these products are serving that kind of requirement. That's why it is called new generation databases. Non-relational in nature, there is no relation at all between one record to other record, one document to other document. Every document can go in one structure, in different structure. Basically, there is no interdependency at all. Every row can have its own number of columns. That's why it is non-relational. There is no relation between the collections or tables, whatever I'm saying, between the rows also. Runs on the commodity hardware, runs on the cheap hardware, because you don't need to buy a server class hardware for this, because you're striping the data, you are minimizing the data footprint on the each set. That way, even it is a commodity hardware, still it scale up. It is open source. Open source in the sense enterprise community edition both are equally good in terms of data processing. There is no limitation except the features. It's not about the data process, it is the features are missing out in the community edition. Schemaless, dynamic schema or schemaless. You don't need to define anything. Even you don't need to create the database also. It'll take the data on the fly. So show DBs I have it. Lab database I have it, right? I'm using the database. I just have to use that's it and run the command. It will build the database. It will take the data in any format. Okay. So I'm creating maybe MongoDB database. Just db.test.insert. Just any data I'm inserting. I did not define anything. I'm just inserting straight away here. So I'll talk about this. This no need to worry. What I am typing, it is dead simple. So now if I go to the show DBs, it got created MongoDB. And you did not create anything. There is no structure. There is no something standard for the database. Nothing. You just use database, create everything. From the code also, you just use and create anything that will create database on the fly, take the data on the fly. Nothing you have to define. So that's what is a dynamic schema means basically. Highly scalable than the RDBMS products. Why highly scaled? Because it follows the horizontal computing model. All RDBMS systems follow the vertical computing model. Vertical computing models might scale, but there is a limitation. At one point, it will go to limitation. When it reaches the limitation, you will see the huge performance impact, right? And highly scalable, which means highly, they can give a good performance, highly available also. Even if one of the database, one of the file is down in the RDBMS, if 1 MB of data is corrupted here, 1 MB of data, 10 TB data will be down. That's how it is. RDBMS database is 1 MB data. If it is lost, you lose the entire, your entire database will be down till you recover 1 MB. These NoSQL families are not like that. Even one chunk, like 20% of the data is not available, it will operate with other available data. So this is called, it does not follow the single point of failure model. RDBMS will follow the single point of failure model. That way it gives a high available data all the time. Supports base property instead of asset property. What is a base property? I'll give a little bit introduction at the end. I have a slide on that. Mostly runs on the cluster. To get this benefit, you need to run it on the cluster. When the data is huge, definitely you have to divide it. So when you have to divide it, it's called a cluster. So to get all these benefits, what I'm trying to talk, you must run on the cluster side. Built for the new generation application, latest application. It's not for the small size application generally. Why NoSQL? Resolves the challenges faced in storing, managing, analyzing, and archiving the data. So whatever the data issues that you have with RDBMS, we are fulfilling the use cases with a NoSQL fam. That's what storing, managing, analyzing, archiving the data. Large data sets you are trying to do, you definitely have to come to the NoSQL. Explosion of social media sites like Facebook, Twitter, Instagram, that kind of all portals, whatever you use it for the social media, absolutely running on the NoSQL family. They're not running on any of the RDBM systems because that you only can scale with the requirement. You never see that Facebook is going down. You never see that Google is never going down. You never see that Twitter is going down. Why? Because they do have this kind of architecture. You never see that even latency also. Why? Because everyone's request is actually fulfilled by different hundreds of servers. That's where you don't see much of latency because systems are absolutely scaling with any amount of load that is coming in. And flexible data model. This is another important. Continuous availability. At any point of time, you never see the downtime. Hardly you'll see the downtime. In case of any, it is a worst case that your entire set is down at any point of time. Maybe one will be down, other will pick up. All are down that is a worst case, right? Entire set is down is a different case. Like maybe that is the worst day of that company. Need of more flexible data model. Nowadays, people need on the fly. They don't want to wait for someone to develop and design, then they wanted to work on it or give it to the market. They want it on the fly, and this product is giving. Still, straight away, people are adopting it. The NoSQL database, great solution to growing scale of databases and the falling price of commodity hardware. See, this product need more storage. The more data, the more storage. The storage device is coming down day by day. So if you take about 10 years back, if you wanted to buy 1 TB hard disk, it used to be 10,000, more than that even. No, 10 years ago there is no 1 TB drive. I guess so. I used to, when I was in my college in 2009, we used to have a like 2 GB pen drive. 2 GB pen drive used to be more than 1,000 rupees. Now you will get for 200. 2 GB pen drive even 100 rupees also on sales, right? You see that the trend of the storage cost, how it is coming down. The storage cost is coming down, the better this product adaptability can happen. Why? Because it runs purely on the more data. The more data means more storage. The more storage is cheaper, the open source is saving the cost. That way you look at the storage, the hard infrastructure is coming at the cheapest cost, even product is also coming at free cost, then you can save a lot of money there. Consists of column-based data stores, key value pairs, database, and document. There are different products. Anyway, I'm going to just talk in the next slide. Offers capabilities to handle large volume of data using the various available features. It uses inbuilt compression to keep large volume of data. Inbuilt compression, 1 TB can become 100 GB itself, right? And it is dividing the data all the time for each write, each read, basically, right? And it is protecting the data with the multiple replicas, and it has a dynamic schema model, more continuity, continuous availability, and everything scaling up compared to. All these are the points which makes to stand out of the market of the compared to RDBMS. Benefits of NoSQL. Again, same thing. Continuous availability, no single point of failure. One shard is down, still operates. Continuous availability. If that is what one shard is down, still it will operate. Multi data center capability. So you can keep two are in one primary data center, one node in other data center. We're going to discuss that how it can be implemented. It is so simple anyway. We're going to see that. So how we can manage that? If it is a different data center, I'm writing here, this is writing it. If it gets failover to this one, what happens? You can design that it should not fail out to this. Only it has to fail out to this only at any point of time. We have all the mechanism to manage. So I'm going to discuss all the use cases that we followed. What we have right now also. We have two nodes in primary data center, one node in another data center. For non-critical, everything in one data center only. We will talk all the combinations when we try to do the configurations. Easy replication for distributed location independent capabilities. The configuration is so simple. It does with one command. One command, it will add the shard into sharded cluster. It does the distribution on its own. You no need to do anything. The entire thing is fully automated. That's the great thing. If I look at the cluster here, I have 1 TB, 333, 333. Here is the data. I'll add one shard. Automatically it does the balancing. Auto balancer. There is a process auto balancer. It does the data migration to make it equal automatically. You don't need to do any job there. You don't need to run any command also to make the data equally in each shard. It does on its own. Okay. High performance with a linear horizontal scalability. So horizontal scalability in the sense you are having the one to like like it is following the horizontal computing model. Vertical means only one server. So it is going the distributed computing model. It is distributing single request to among all of servers in the background to serve your request. Flexible schema support that we have seen and discussed. Easy to implement and maintain and grow. It can grow to any extent of the data. The data is growing. The more shards you add it, the data will keep scaling it. There is no limitation. There is no limitation on number of shards that you want it to add. It can go to any numbers. Thriving open source community. All NoSQL family give a like a free version, which is as good as enterprise, a paid version, except the features. All that's where this is actually attracting the market, I would say, because these people are only operating the product with a 10% billing, 10% billing, 90% is free. People are using it that way because it is giving that processing power. There is no limitation on the CPU or memory or anything on the community. If you come to RDBMS in any product you go to, they limit the resources on the free editions basically. That way you definitely have to go to the paid version. Here you can run as much data as you want on the free edition. That something is good. Right. If you look at the comparison wise, rigid fixed schema model. Always it will take only fixed schema model. If I am exceeding some column data, it won't accept it. You have to fit into the backend schema design. Only three columns data only you have to give it. That's why it is fixed and rigid. It is dynamic. Vertical scale, only one machine will serve at any point for read or write at any point of time. Horizontal scalability, a lot of machines will read, a lot of machines will write. Depends on the scenario. Difficult to handle big data. When data becomes huge, you cannot do the maintenance. If you cannot do the maintenance, you're gone with the performance. It can handle any data because you are striping the data and managing it. Mix of open source and proprietary, mostly proprietary. All RDBMS, even Postgres, Postgres is open source. It is very buggy product, and you have to go to EDB. You have to go to different, second quadrant. Different people are there who does support that product in case of bugs, basically. But here, MongoDB is absolutely taking end-to-end support. No third party involved here. No one in terms of distribution, in terms of support model, everything purely Mongo. No one is there in between. Standalone. Generally, we run the server standalone. Cluster servers are very few which are critical. Here, we definitely run in that cluster to get the benefit of data processing. That's important here. Single point of failure. One file is down. You have hundreds of files in database. Still, database is down. One file is 99 files are available. Still, database is down. Here, it's not like that. No single point of failure. Even one shard is down, you don't see the downtime. Asset properties, base properties. Asset properties, I'll talk in a while. One slide I have given. Need of server class hardware. You need a best sophisticated hardware to process the data. Here you don't need it. It is costly, very costly in fact. It is average compared to this one. If you're compared to this one, maybe you might run this infrastructure on the NoSQL 40%. it is 100% for 60% saving can straight away get it, though you run on the entire enterprise. What you're running on the RDBMS side, you are running both enterprises, RDBMS enterprise, Mongo enterprise. If you compare the charge wise, 40% you will pay, 60% is less definitely. RDBMS licenses are so costly compared to NoSQL. Different types of NoSQL. There are many things in the market. Even I did not work on this except MongoDB. This is what I worked on the NoSQL side. Redis server, Memcache, Calories, MongoDB, CouchDB, Rabbit. I just heard the names, but I never got a chance to work except MongoDB. Right. Big data means what? Big data is a data any that contain, that cannot be handled and processed through traditional one system. One system cannot process data, processed by multiple servers. Big data involves billions of users, millions of queries, billions of rows, wide variety of activities at the same time. Absolutely. One is reading the Facebook, one is writing the comment, one is loading the video, one is doing something else. So variety of actions are happening at the same time by billions of people around the world on the same domain. So it is possible only with a big data. It will talk about volume of data, which is too big, variety of data, structured, semi-structured, unstructured, everything, velocity, speed of the data retrieval, the scalability of the data. So 3 V's will talk about the big data. These are the big data features, in fact. Vertical scalability, if the data is growing, increase the CPU on the same machine, increase the RAM on the same machine, increase the disk space on the same machine. You don't go to other one. High cost, downtime, threshold and limitation. There is a limitation to grow to the certain level. Single point of failure. One is down, one drive is down. Out of all the drives, your database will be down still. Single point of failure. These are all limitations, right? You're getting it, I guess. These are all limitations. When it comes to the NoSQL family, servers are actually processed in a parallel fashion into different servers. As the data is keep growing, add more machines. As you add more machines, the scalability, availability both will increase. Less cost and no downtime, no limitation on the data, no single point of failure, can be scaled down with a huge data. This is a main difference between this and this basically. And dynamic schema model, data compression, and continuous availability, right? Scalability. There are all these points are considerable, very considerable points, right? Now, let's talk about this. Atomicity and base property. Atomicity says that no transaction left in half-done status. Either it has to be rolled back or rolled forward. It should not be left in between at any point of time, right? So this atomicity is something, it will make sure the data integrity internally. It is same all the time. This committed means committed, failed means failed. Consistency of your data basically can be maintained by your referential integrities basically, right? Your integrity of your data basically. Isolation one at a time, one transaction at a time. If someone is writing the data, there will be a lock, and after the lock release, then only someone can go to the same data. So that is isolation there in the even in the Mongo also. Durability, your data once is committed means committed. Basically, it never go to wrong state. Basically, whatever you return is written. It is committed. It is there. It never change on its own. It is whatever you return. It is written. That's it. It won't change on its own. All whatever the data is there in the system. It will be written means written. That's it. So though your transaction is actually consistency will take, your system is all of a sudden restarted, it will look for the undo transactions, redo transactions, and it does. When the data got written, it is written. Even it is no disk is not available, when it comes online, your data will be there. Durability means your data is all the time same. It won't change on its own basically. Basically available soft, the base property full form is basically available soft state eventual consistency. So here, whatever the data you write, it is asynchronous replication by default, basically available on other copies, eventually consistent. Whatever data you write it will go and write into other copies eventually, not immediately. It is not synchronous, it is asynchronous by nature. Data transmission between the nodes is asynchronous by default. If you wanted to make it synchronous, you can do it transaction level, not the server level. Server level synchronous is not possible. Transaction level synchronous, you can do it. How do you do that? When you're writing itself, you have to mention that, write concerns, read concerns. We have that. So we're going to see that, I mean, in practical. Okay. So this is different. It talks about replica set. Base property will talk about replica set basically. This talk about entire one RDBMS system properties. Okay. Then uh, MongoDB, like download by Tengen. Tengen itself is termed into MongoDB. So it is actually renamed to 2000, I guess, 1999. I'm not sure when they have renamed to MongoDB, but the old name of MongoDB is Tengen. It's not someone else. Tengen itself renamed to MongoDB. MongoDB Incorporation is a company name actually, and this is something data model querying. Anything whatever this product is giving, no third party company is involved, no third party support model is involved. Everything is owned by MongoDB only. Every enhancement is done by the MongoDB only. No third party person is giving the enhancements or giving to this product and they are adding. No, absolutely everything is in the MongoDB hands only. So this is about NoSQL introduction. It's not specific to MongoDB itself. NoSQL introduction. Why NoSQL is gaining the market? Because of the use cases what we discussed just now, right? What are the use cases we discussed? Availability, continuous availability, no single point of failures, right? If one thing is goes on, data compression, automatic data compression, and horizontal computing model and licensing model, community edition, it is open source model, dynamic schema model. These are all considerable points. What I'm trying to say, it's not a small point. It is giving the cost saving, it is giving the availability, it is giving the scalability, it is saving the cost by compressing the data, and dynamic schema model. It is all very considerable points to switch from one product to another product, right? So this is such an important thing, right? So quickly, what are the things we're going to cover? Let me show you the content once, because this is important to know for everyone. So just for the sake, did I post I'll give all this at the end to everyone, no need to worry. I guess somewhere I posted the course content right here. I mean, I'll run through quickly. So guys, first we go with the introduction to MongoDB is done. Linux administration. First, I'll make you familiar with the operating system. Okay, you need to know, because this runs mostly on the Unix platforms. Even it runs on the Windows also, that I'll show you on the last class, on all platforms. First we will start this product on the Unix platforms. How this product runs on all platforms, Windows, Mac, and Unix, all the flavors, anywhere. It runs on all the platform, multi-platform, compatible this product. So first we will understand the Unix basics, first three classes. Next class, Unix basics only, like how you can create the directories, how you can create the files, how you can move the files, how you copy the files from one server to the server, how we can verify the communication, how the ports are opened basically, how we can start the Mongo, and the ownership of the service account, how you create the account, giving the permissions, passwords, and basic, what we need to know as a DBA, that I'm going to cover. You don't need to get into in-depth of Linux administration or Unix administration. We are not the OS administrator, we are the product administrators. So what we need to know towards the product administration, I'll cover all that basics first, then we'll start the Mongo installation. 3 classes or 2.5 classes we'll spend, depends on your question, and generally it requires 2 classes only. 3 classes I can take up to, depends on the discussion it goes again. First we'll cover the base platform, the Mongo where it runs, okay, and architecture. We will cover here itself, installations and all that. Architecture is very, very, very important. This is where the most of the questions you get from the interview. We'll spend 3 to 4 classes on architecture especially. what kind of architecture MongoDB follows, how does the recovery happens if the Mongo restarts automatically, what are the different types of storage engines we do have for the MongoDB, and what is the main differences, which one is good, which one is bad, what is being used in the market, we're going to spend there. This is very, very, very important. CRUD operations. As a DBA, we will review the script sometime, right? So I will make you write yourself also, you can write a script. We'll spend 3 to 4 classes on the CRUD operations. Anybody can write their own script, automation scripts if you want. There is an automation module, we have it. How do we automate on the Unix shell? Basically, any command that you wanted. In terms of product side, in terms of OS side, we have the automation discussion.
Uh,
Maybe you
so,
wanted.
sorry, Ravi, to ask. So automation in the sense you will cover using shell scripting, or you will go with Python, something like that, Ravi?
No, shell only. Shells using, like, you wanted to automate the MongoDB backup. You wanted to recycle the Mongo files. So it is towards the
Okay.
product, not towards the programming side. It is towards
Okay.
the
Okay.
Mongo administration side.
Understood. Okay. Okay.
So then we'll go to the schema design data model. This is something, like as a good DBA, you must have that knowledge. So all that will be covered. Then from index onwards is purely administration, absolutely 100% administration. First modules talk about your development skill set. Architecture is something you must have it. CRUD operations also we must know. It's so simple. Any LKG guy can write. That simple it is. JSON script is dead simple. You'll understand. You get more confidence than what you are working on the products right now after this course anyway. That's how I'm going to make you familiar. Schema design, indexes especially displays very, very bigger role. And this is where I'm going to spend a lot of performance, including indexes, looking at the execution plans and tracing the load, finding the right issue at that moment. We're going to run the profiling, we're going to trace it, we're going to read how we can read the data from the profiling, how we can identify what is the issue at the moment is causing. We can simply close outage in 10 minutes if you follow all the classes that I'm going to discuss during the performance training, because I use the same methods what I discuss in the class. Administrative commands, this covers a lot of things. In fact, upgradations, general administration, and migrations, a lot of things will be covered under administration. Backup and
Uh,
security. Yeah.
so migrations in the sense, right? So through which DB to which DB you will be showing, or
Migration to Mongo to Mongo, like server to server, how you migrate, data center to data center, on-prem to cloud, Mongo to Mongo.
any scope of migrating any one RDBMS to MongoDB use case we have, Ravi?
It is so simple. We have one tool.
Okay.
The tool does the migrations. It one single click away, it will convert the data. Example, simple. All products will support the JSON scripting. So if I wanted to move this table data into MongoDB, as you mentioned, this is the output, or else big output maybe. You wanted to convert this data into MongoDB, this particular data. So
Okay.
if it is on demand, as in my case, on single table, database is something different actually. But single table, if you wanted to migrate from SQL to Mongo, we do sometimes. So for JSON, I'll show that. JSON auto. If I run this command, it will generate the JSON script for that output, table output. I'll pick up this. I'll go to here. I'll table migration. Simple, straight away, no tool, nothing. So insert db.test.insert many. Small function you have to write.
Okay.
That's it. And I'll take this data, run in the Mongo. You converted the data, that data db.test.find. You will have all DBMS data into Mongo now. I mean, I'm showing just a small example.
Okay.
So moving it is so simple. These products actually, there are multiple third-party tools. When the data is vast, you cannot do like this in traditional method. Small data, you can do it. Data is big, you cannot do it. So that time you need a third-party tool, a paid tool.
Understood.
So we'll see that anyway. I'm going to
Sure.
we migrated MongoDB data to a SQL actually through using a tool. I'll talk
Okay.
about it. Where I was actually right here. Administration and backup security, recovery of the data, and securing the MongoDB, different authentication method, permissions. What are the permissions we do have? And we'll talk about replication, replica set, and replica set is a main discussion for us. Scalability comes under sharding. Here it is a sharding. Monitoring tools and administrative tools and automations, everything will be covered here basically. So the like a course is divided into 10 modules, and all will be give you very in-depth discussions. It's not like what is what. I'm going to share all my experience that I went through in my career. It's not what is what. Seriously, you get a lot of use cases into your hand. If you follow this, you can crack first interview, because many people cracked it. First thing is you have to follow every class. That's important. So any
Ravi, what
questions?
is the duration?
Duration is 35 days. I mean, that is towards subject. Any questions? I'll stop the video and talk.